But the handout that I gave to you, see right here, this is your site. I do have a different section, different site. This is now online site. This one I gave to you right now, just what, 15 minutes ago, right? So I hope that I will have time for this. I also include what? Guess what? Unlike other demonstration problem, I include the full solution. Do you see that? All right. But what I gave to you is just question today. I didn't go through amortization schedule. I didn't go through bond issuing discount, bond issuing premium yet. So I'm just letting you know right now where things are. Because just wondering, some students say, well, you said somewhere where, right here. And then this one is the one that I'm going to use today's. I didn't make hard copy for this. It's a comprehensive example of bonds. I'm going to teach you amortization schedule. This is a little bit too small. I don't, okay, well, it's too big. Okay. I just create the question. You have similar question in your textbook. So amortization schedule, here's the straight line, here's the amortization schedule. And this should be right here. It's not perfectly lined up. Right? So I'm going to show you how to develop, how to prepare, and how does that connect it to each other. So this, what you see is the bonds are issued at discount, rolling up to the maturity value, $100,000. I'm using $100,000 as an example, just like your textbook example. So I'm going to go through that. The 1-4 discount, it's the same example, So you can print this out at home, but I'm going to go through today in class using this same number. Okay. So 100,000, 5 years, 12%. That's the contractual rate. And then I already gave you what? Present value table factor, so you don't have to look through it, or you don't have to punch in the calculator. I gave you present value at 10%, present value of 14%, 1 for what? Single sum 1 for? Oh, no, I gave you each one, so we can do that easily. And ideally, I need another column at 12%, so I want to intentionally making contractual rate same as market rate. So again, I'm not starting this now. I'm just doing a preview here for you to know where things are, all right? And then your textbook has a very similar, your textbook has many similar examples. Just 1 second. I think I know where things are. Your textbook example, this is your textbook, has an example like that. 100,000, 5 year, 10%, and 96. So my example, your textbook example, we both using 100,000. So just in case you don't. Anyway, so before I start, any questions? Time value of money. So what we learned was so far time value of money, present value, future value. But that's not the final destination. Why we learned this is because bonds, pricing of bond pricing is close tied to this. Right? How did I define bond pricing the other day? It's a bond pricing is determined by discounting future cash flow of the bonds. Well, what's bonds? Embry. If Grandma asked you, Embry, I understand you took accounting 1B. What are bonds?
It's like a promissory note kind of thing where
right.
like we give the money to the company to borrow and they give us a certain return on it.
So, and contractual return, that's right.
Yeah, they give us a return, and then whatever the maturity date is, 10 years, 20 years, then we get a certain amount of money.
That's pretty good. I like that, right? I like that. Written promise, corporation giving money back at the predetermined contractual rate. I like that. Right? And then, but I'm going to keep on going today. And then I'll ask you, well, Amber, I don't mean to spot on you. how does that differ from loan from Bank of America? Same amount, right? So we're going to get into that. But I don't want to get off the sidetrack here. Bond pricing is discounting future cash flow discount. Right? So that's the reason why we learn. And then today I'm getting into issuing bonds. Issuing bonds. Finally. But I'm going to show you two different ways. At a discount, at a premium. By doing that, I'm going to create amortization schedule. What does that mean, amortization? Word amortization also has to be defined here. It's a little bit different from word depreciation, depletion, amortization we had learned in chapter 10. Amortization schedule over the life. Whose life?
The bond.
Over the life of the bond. When you're servicing the debt, it is a long-term debt, as Ambrose said. Right? So by doing that, you really have to understand how does the compounding interest versus simple interest works. Because when I doing amortization schedule, I will do two different ways. One is the straight line amortization. The other one is effective interest method. Your textbook talked about both. Most textbooks start with straight line. Can I just do straight line essay there, like that? You understand it, right? Straight line. I don't have to write it out. Straight line amortization first. Then they talk about effective interest method because it's harder. But this effective interest method is closely tied to compounding interest. When we did timeline the other day with $100, so that's that. That's effective. And then after that, we're going to talk about types of bonds. And bond rating. In other words, risk involved. That's another item that we have to talk about there. And then we're going to do some exercise in the textbook. So we're going to talk about debenture bonds, unsecured bond, secured bond, term bond, serial bond, convertible bonds, all those in the chapter. All right. So before I talk about straight line amortization effective interest method, let's talk about compounding interest rate, interest earning versus simple interest earning first, because it will be helpful when I'm creating the amortization schedule. I'm not sure I talked about this enough in my first video session. That's why I'm doing this. Do you remember that present value we did a few years, $100, compounding, $100 at 10%, 110, 121, 133, roughly at 10%. And then I ask you to do, just pretend you don't know 100. If it's 1 year, 2 years, 3 years. The 3 years from today, $133. How much will be the present value? What is your answer? $100. First, we did this way, right? We did this way. At 10%. 10% doesn't change. So $100 become 110, right? Anybody? $110 become 121. Right? So the compounding meaning we are not taking out any interest, or we are not taking out any principal. The $121 will be roughly $133. There's some pennies, right? Right? Is 133 correct? Okay.
Yes.
Just want to make sure. Right? But I want you to pay attention to something here. What's the interval?
A year.
The first 1 year. First 1 year. Yeah, everything is 1 year. But I'm talking about interval, incremental amount. The first year is only 10. Second year, 11. Third year, 12. Wait a minute. Something, I mean, it's a constant 10%, but accelerating. Something is not accelerating. Right? 1, 2, right? Increment. This concept is also key to understand effective interest method, not the straight line. If it's a straight line interest method, it could be 10, 10, 10, 10, 10, 10, 10. So I'm going to show you, but I'm just doing the preface with this concept. I just want to plant this in your brain before I go to effective interest method. I know it's a compounding interest method. It should be a high school topic. I agree with you, right? But it is important. So oftentimes, I don't know what I did this. I talked like this in the winter, good snow. This one of those winter. We had good snow, good powder, soft powder. We go up to Lake Tahoe, South Lake Tahoe. What do you have? Ski resort, heavenly. On top of the mountain. Have you ever gone to Heavenly Valley? Ski? Nobody ski? Sledding? So you can came down one side, that's California side, the other one's the Nevada side. Because I guess Heavenly happens to be sitting right on the borderline, am I right? Between the two states. So think about you in the middle of the winter, heavy snow, good powder, snowball. You just make one snowball in your hand. You drop the snowball from the top of the mountain to the base. The snowball rolling down, rolling down, rolling down, rolling down, rolling down. So Troy, what happened at the bottom?
Accumulated?
Yeah, accumulated. So size of the snowball? Bigger. And also, please describe how does that happen along the way? Speed, acceleration. And we're talking about Newton law, right? What's the law of gravity? So picking up the speed, accelerating as you get closer to the center of the earth. Right? Area of the snowball is bigger, so therefore you are adding more snow. That's the compounding interest rate concept. So how does that work in terms of number here, 10, 11, 12? It's because, what would you say? Not only the original principal amount of $100, that's the original principal amount. Not only the principal amount earning the interest, but also it's a $10 interest you earn in first 1 year will earn interest on interest. How about that? Earning interest on interest you previously earned. Earning interest on that interest you previously already had earned. Accelerating, right? So that's important concept.